The sky records events with a patience older than oceans, and in that deep ledger a thin, incandescent stroke now appears, an interstellar body sluicing through the heliocentric dark, leaving behind not the soft, random veil of a comet's breath, but a repeating grid of dust, an etched geometry so clean it feels like a proof made visible. We gave it the name 3I Atlas because names anchor storms, and this is a storm with a trajectory that refuses captivity. The orbit is hyperbolic, eccentricity well above 1, the velocity at infinity carrying the accent of another star's gravitational school. Hyperbolic paths do not circle back. They pronounce a once-only sentence in the grammar of celestial mechanics. Its speed, its line, its spectral demeanor, icy volatiles flashing under sunlight, initially placed it among the small clan of interstellar infiltrators, kin to Oumuamua and Tue Borisov. But this one speaks a second dialect, a lattice. In close images and in the delicate arithmetic of light curves, the coma brightens and dims in steps like a staircase whose risers are equal to within a fraction of a degree. The tale is a page. The page is ruled. Where ice and rock should shed chaos, we witness order, and order in physics is an invitation to look again. We followed with every tool that could be swung toward the sun. Broadband photometry gave us color, a slightly reddened spectrum consistent with complex organics dusted across silicate grains. High dispersion spectroscopy hunted for the usual cometary suspects, CN bands, C2 swan bands, OH fluorescence, and found them faint, intermittent, and oddly phase-locked to the object's rotation. Polarimetric observations, which test how sunlight scatters off small particles, mapped an angle-dependent swing that repeated with a cadence matching the brightness peaks. Plot the polarization as a function of rotation, and you don't see noise. You see a picket fence. The coma, seen through coronagraphs and lucky imaging runs, breaks into cells, zones of enhanced grain density separated by corridors of relative clarity, hexagonal tendencies emerging like frost on glass. In the power spectrum of its light curve, harmonics fall at prime-weighted intervals, an imprint eerily congruent with a hexagonal lattice adrift and rotating in the solar wind. Hexagons, nature's efficient tilers, might appear in basalt columns and convection cells, but to watch them assemble in a comet's breath in open space is to feel our definitions flex. If dust is the ink and the sun is the press, then outgassing is the pressman's hand, unsteady, thermal, chaotic. Yet the acceleration terms we fit to the trajectory, those tiny nudges from jets of vapor and dust, are not a shrug of randomness, but a mantra. The standard non-gravitational model uses components A1, A2, A3 aligned with the comet's orbit, the radial, transverse, and normal thrust that outgassing produces. In 3I Atlas, those components do not meander, they tick. A1T shows a gentle square wave modulation. A2T echoes it with half amplitude. A3T hums at a subtle third harmonic, all synchronized to a rotation period that itself appears locked to the geometry of the dust cells. Sublimation should breathe with temperature alone, noon versus midnight on an airless rock. Instead, we see an internal metronome, as if vents were gated by a structure deeper than sunlight. The particle size distribution, inferred from how brightness decays with wavelength, is oddly discrete. Preferred grain radii cluster in narrow bands rather than forming a continuous power law. Taken together, the motion, the dust, the light, they compose a fugue, not a roar. A jet turns on, a cell brightens, the lattice tightens, a jet turns off, corridors widen, the polarization angle flips, tick, tock, tick. At this frontier between sense and symbol, hypotheses crowd like birds on a wire. The conservative anchorage is a resonant nucleus, a rubble ice aggregate whose internal fractures and voids produce mechanical modes, phonons writ large, that repeatedly open and close fracture mouths as the body spins. Picture panes of brittle ice laced with hydrates and organics. Stress waves reflect through this honeycomb, and at certain rotation phases, the mouth of a vent reaches its critical aperture, snapping open to shed a train of grains, then snapping shut before thermal runaway occurs. Over time, multiple vents in different longitudes leap into phase lock, a planetary scale pendulum clock made of ice. More daring is the idea that the lattice is an emergent diffraction device. Let jets emit dust with phase-regular spacing, and the tail becomes a kilometer-scale grating, modulating sunlight and radioplasma alike. An optical and magnetohydrodynamic signature visible across astronomical units. And then there's the long shadow of intention, the engineered relic theory. Perhaps the lattice is a robust way to broadcast across light years, encoding prime-weighted geometry because primes do not grow in volcanoes or rivers. They grow in minds that count. Such thinking is intoxicating. Science insists we sip, not guzzle. But the data keep refilling the glass. Coincidence is the most common miracle in astronomy because we observe so much from so many vantage points that alignments happen. And yet the timing here sits in our chest like an extra heartbeat. The object's perihelion, its closest approach to the Sun, arrived during a window when Earth, Mars, and a constellation of solar observatories found themselves arranged in a loose isosceles triangle, giving our interferometry unusual leverage. At the same time, the solar wind entered a relatively quiet phase, smoothing the plasma that otherwise shreds comet tails into ragged streamers. The calm turned the tail into a still pond where ripples write clean circles. The lattice contrast peaked within this lull as if it sought the quiet. Meanwhile, on Earth, 2 independent radar facilities were scheduled for maintenance, closing the only eyes that could have pinged the coma with centimeter precision. It may be nothing more than the dice coming up snake's eyes, a cluster of events with no causal thread. But it's difficult not to note that a geometry designed to be seen became maximally visible precisely when our geometry for looking was best and our radar voices were silent. To quantify beauty is to keep it honest. We ran the orbital dance forward and backward, integrating 3-eye atlas through the sun's gravity and the minor tugs of planets large and small. The path threads a corridor near Jupiter, grazing the 4-1 and 3-1 mean motion resonances without being captured, a tightrope walk through a garden of powerful oscillations. Small changes in the rocket effect thrust from outgassing produce measurable precession of the spin axis. That precession drifts the dust release nodes, those latitude-longitude points on the nucleus where jets find purchase, so that over weeks the tail's lattice sweeps through heliocentric longitude like a lighthouse beam. Simulations that marry the jet gate model to the solar wind's Parker spiral show that grain trains released at specific spin phases intersect with periodic pockets of enhanced magnetic pressure, which compress the lattice cells along one axis and elongate them along another, sculpting hexagons from circles. The grain sizes selected by the nucleus, a few peaks around submicrons, several microns, and tens of microns, ride the wind differently. This polychromatic drift stretches some cells and shrinks others, yet the overall grid persists. Gravity curves the grand path, sunlight writes the small letters, and plasma breathes between them, 3 hands on the same instrument. Then came the silence. Solar conjunction, the alignment that buries an object in sunlight from our point of view, fell across our observing schedule like a shutter. Cameras cooled beneath the same sky they could not read. For days, the object lived only in ephemerides, those predictive tables where numbers impersonate reality. When the line of sight cleared, we turned our mirrors back and found that the lattice had changed, not dissolved, transformed. The characteristic spacing between brightness cells had halved, a clean factor of 2, as if a higher harmonic of the venting clock now dominated. Temperatures had not doubled. Sublimation rates had not jumped by discrete steps. Nature rarely plays on-off with such mathematical crispness. Our radio telescopes, denied earlier by maintenance, now returned in time to hear the interplanetary medium itself report a change. Plasma wave instruments aboard solar probes tasted a rhythm of density fluctuations coincident with the new lattice scale. We blame coincidence for human comfort, but coincidences that march to a ratio begin staking a claim that we should audit. And we audited with everything we had: cross-calibrations, independent pipelines, deliberate attempts to break the pattern. The pattern held. What then could a lattice say, if indeed it says anything? A grid is an alphabet for Fourier space. Periodic structure turns the sky into a spectrum of peaks and troughs, encode numbers in the ratios of those peaks, and you speak in a language robust against noise. If sunlight passing through the tail exits with a comb of brightness intervals whose ratios spell primes, you have an announcement that is difficult to forge but easy to read. Perhaps the lattice is a natural byproduct of resonance-locked venting, a physics art that merely looks like a code. Perhaps it is both, a natural instrument tuned by the quiet clock of mechanics, pressed into service by some ancient or absent will. SETI, the search for extraterrestrial intelligence, has long pointed its ears rather than its eyes, because radio is cheap in the void, and the interstellar medium is forgiving at certain wavelengths. But geometry travels too. Dust is abundant, structure spins, and sunlight is a universally available backlight. If you were to send a beacon that survives eons and ignore the vulnerability of electronics, you might choose something that the cosmos itself is good at: lattices, harmonics, ratios, and ask a star to illuminate it. Caution is our compass, but curiosity is the charge in our engine. To test nature's hand against intentions, we propose an audacity that feels like necessity. Fly through the letters of the dust, not past, not around, through. A fast intercept craft would ride a solar sail inward, then pivot onto a powered arc to meet the tail obliquely, sampling the lattice cell by cell. Its instruments would be more choir than spectrometer: polarimetric imagers to measure the angle-tuned brightness, phase function cameras to read how grains scatter light at every direction, a dust mass spectrometer to taste isotopes, looking for anomalies in deuterium ratios or noble gases that would write an origin story. Microcalorimeters would try to record the tiny heat pulses in the wake of grain impacts, searching for coatings or layered structures that betray manufacturing or unusual formation. Radioplasma sensors would listen for a beat imposed on the solar wind by the lattice. If the pattern is natural, it will likely blur with proximity. If it is a code, it may sharpen as we resolve its constituent strokes. Either way, we learn. The wider future bends when we let anomalies steer. Suppose the lattice is born of resonance alone, a demonstration that rubble ice bodies can entrain their own fracture networks into global phase lock under the right spin and temperature gradients. We would rewrite our models of comet activity, deriving vent gates from phonon spectra, predicting when and how jets synchronize. The payoffs are immediate. Better non-gravitational force estimates lead to more precise trajectories for small bodies, improving planetary defense. Materials science would inherit a challenge: probe ice organic skeletons at cryogenic temperatures to see how stress waves breed repeatable fissures. Planetary formation theories would drink from the same stream, modeling how internal resonance in pebbles and planetesimals could steer volatile loss and alter planetary chemistry before worlds even wake. Or suppose the lattice is an artifact, intended or incidental, of an engineered object. Then the sky has spoken with geometry, and our instrument making changes overnight. We would design not just ears, but rulers, deployable diffractors that can read prime-spaced peaks at great distance, constellations of microsats that fly formation to sample tail structure as a distributed interferometer. We would teach algorithms to read numbers not in bits or wavelengths, but in lattice spacings. SETI would expand into SETG, the search for extraterrestrial geometry. With or without intention, the lesson is discipline allied to wonder. We live between two masters. One asks for parsimonious equations. The other whispers of horizons beyond the last theorem. Brian Cox would remind us that the cosmos wears beauty because its laws are simple and deep. Michio Kaku would invite us to dream what might be made if those laws are bent with purpose. Here, in the narrow wake of 3I Atlas, the two voices converge. The sun, by shining, becomes a transmitter. An icy fragment, by cracking, becomes a modulator. The interplanetary medium, by breathing, becomes an amplifier. Whether or not there is a sender, there is a message. That structure survives the abyss. That patterns can be written in materials destined to evaporate. Future missions will not simply chart orbits. They will choreograph encounters with patterns. Laboratory teams will build vacuum chambers where ice blocks spin under a lamp, measuring when fractures sink and when they fall into noise. Theorists will do the stern work of pulling primes out of plasma only when justified and kicking them back into accident when not. And across it all will be the appetite to go again to the next lattice and the next, until repetition births understanding or the extraordinary reveals itself by refusing to be ordinary. There is a human dimension to this, a philosophical gravity that holds us as surely as the sun holds planets. The lattice makes us think of writing, of mathematics, of the old dream that numbers are the bones of reality. Perhaps that dream arises because our minds are built to detect structure, to raise signal out of chaos for survival and for art. If the lattice is natural, it is an anthem that nature plays for itself in the register we happen to hear. If it is intentional, then somewhere a mind-shaped grains and hecta. Monics to bridge the terrible loneliness between stars. Either way, the effect on us is the same. We are moved to reach farther. We can imagine our grandchildren sitting at consoles, not pointing dishes at the sky, but laying out rulers across images of dusttails, debating whether the ratios they measure hum with the impossible purity of primes or sag into the warmth of approximations. They will argue, publish, revise, and in the process their instruments will become better, their thoughts clearer, their ambitions steadier. This is what anomalies do when treated well. They elevate us. And so we end where we must begin again, with a thin stroke of brightness on the night's face and a suspicion that dust can do more than drift. 3I Atlas arrived, sang in ratios, and will depart to a cold beyond the arithmetic of our telescopes. The geometry it left will unspool and fade as photons push and scatter its grains into wider, softer veils. But the memory of pattern is itself a pattern, and that we can carry indefinitely. What is next is already taking shape in CAD models, in grant drafts, in lectures, and late-night scribbles. An intercept fleet with polarimetric eyes, a ring of microsats that fly through tails the way a needle follows grooves, algorithms that can distinguish code. From chorus, we will honor the conservative path, testing fracture physics, cataloging coma morphologies, mapping the dependencies of lattice strength on spin, temperature, and composition. We will also keep a corner of our mind ajar for the future in which geometry is not merely beautiful, but communicative. We can be both hard-minded and open-hearted because the universe, when presented with serious attention, rewards both traits. The sky writes, the sky reads, and we, for a moment, are the pen and the eye